Hello, grade 11 students. My topic this time is about general annuity. Objectives. Number 1, define and illustrate general annuity. And number 2, find the future values of general annuities. Last time you learned about simple annuity. Let's see its difference with general annuity. In terms of definition, simple annuity is an annuity where the payment interval is the same as the compounding interval. For example, if the payment interval is monthly, then the compounding interval is also monthly. While in general annuity, it is an annuity where the payment interval is not the same as the compounding interval. So for example, if the payment interval is monthly, then it is possible that the compounding interval may be quarterly or annually. Let's have the following examples to compare simple annuity from general annuity. In terms of example, we have the following simple annuity, quarterly installment payment of a car, lot, or house with an interest rate that is compounded quarterly. So if you notice, the payment interval is quarterly and the interest or compounding interval is also quarterly. So the same payment interval and compounding interval. This is simple annuity. While in general annuity, the example is monthly installment payment of a car, lot, or house with an interest rate that is compounded annually. So for the payment interval, it is monthly, while the compounding interval is annually. They are different. So again, if the compounding interval and the payment interval are different, then the problem is about general annuity. Now let us focus on the examples of the future value of general annuity. This is the formula to find the future value of general annuity. If you notice, the formula is the same as simple ordinary annuity. But the only difference is we have to do extra step for us to find the value of J. So again, the terms are the same. Let's say for R, it's the same regular payment. J is the interest rate per period. So here, we need to solve this further. In the next slide, I will show you the formula for J. And N is the number of payments. How do we solve for J? This is the formula. J is equal to, open parenthesis, 1 plus R over C, close parenthesis, raised to C over P minus 1. Where R is the rate, P is the period or payment method or the payment interval, and C is the compounding type or compounding interval. In the next slide, as we solve the example, you will understand how to apply this formula. Example number 1 for general annuity looking for future value. Meg started to deposit 1,000 monthly in a fund that pays 6% compounded quarterly. How much will be in the fund after 15 years? So this is an example of general annuity because the payment interval is monthly and the compounding interval is quarterly. Different types of interval, monthly and quarterly. So this problem is really general annuity. And this is looking for the future value because the question here is how much will be in the fund after 15 years. Following this formula, we cannot proceed right away unless we know the value of J. So we have to solve first for the value of J here. J is equal to 1 plus, let's copy 1,
plus R over C. R is the rate, which is 6% or 0.06, and then over 4 because it's compounded quarterly. So R is 0.06 over 4, and then in close parentheses, C again is 4 over P. P is the payment interval. Here it's monthly, so that's why it should be over 12. And then simply copy minus 1. Solving this will give us 0.00498. This is already rounded off to the nearest 5 decimal places. So let us agree that when we look for the J, the value should be up to 5 decimal places. Now that we have value for the J, then we can already use the formula or continue the formula for F. So F equals R should be replaced by 1,000. So 1,000 is the regular monthly payment. And then let's copy 1 plus J. This time we can write J as 0.00498 based on our computation. And then raise to N. How do we get N? N is referring to the number of times that Meg should deposit 1,000. So if she will deposit 1,000 monthly, it means to say 12 times a year, and the target number of years will be 15, so 12 times 15. N is 12 times 15, which is equal to 180. So N therefore is 180. So raise to 180, then copy minus 1. All over J, which again 0.00498. So using calculator, let's solve this. The final answer is 290,224.58. This is already rounded off up to 2 decimal places. This is the amount or the future value that Meg will get after 15 years. Example number 2, Art saves 5,000 pesos every 6 months in a bank that pays 0.25% compounded monthly. How much will be his savings after 10 years? So again, this problem is about general annuity because the payment interval is every 6 months, which means twice a year, or semi-annually. Semi-annually. While the compounding interval is monthly, meaning to say 12 months if it is monthly. How much will be his savings after 10 years, which is asking for the future value? Let's start solving this by simply looking for the value of J. Before we look for the value of J, let us identify the following. So R refers to the rate, which is 0.25%. Then change it to decimal. We'll have 0.0025. Next is C, which is the compounding interval. So it says here compounded monthly. That's why C should be 12. And for the value of P, this is the payment interval, which is every 6 months. So it means to say twice a year. So simply write 2 semi-annually. It's not really 6 times because of the word every, which means twice a year. Semi-annually. So your P should be equal to 2. Following the formula, let us now solve for J. J is equal to 1 plus R is 0.0025 over C, which is 12. Then close parenthesis raised to 12 over 2. C over P is 12 over 2. Then minus 1. Using calculator, the value of J is 0.00125. So this is the value of J. So from here, we can now proceed to solving for the future value following this formula. F is equal to R should be replaced by 5,000. Then open parenthesis 1 plus j, which is the computed value of 0.00125, close parenthesis, raised to n. So n here is equal to the number of payments. So if Art will save every 6 months, that means twice a year. And he has to save for 10 years. So that's 2 times 10, which is equivalent to 20. So n should be 20, raised to 20. Then copy minus 1 all over the value of j again is 0.00125. Using calculator, the result here is 101,196 pesos, 0.45. This is the future value or the amount that Art will save after 10 years. That's all the different problems or the two examples about general annuity involving future values.